So, let us start lecture number 9 of this module 2, that is a converter analysis. And last turn in lecture 8 we saw that when u is more than 60 degree, then we are going to have the commutation, means it is a 3 to 4 valve conduction is appearing. We derived the various currents at that time. If you remember, here we defined once your 1, 2, 3 are conducting, even though before here I said your 6, 1, 2 were conducting, and then we give the gate pulse to 3, it was conducting. We derive the current expression here. Now you can see in terms of here we are getting the currents. Then what happen, the commutation between 6 and 2 will be over, 2 will take care, then current 1, 2 and valve 1, 2, 3 are conducting, and then expression becomes here. We derive again, and the current equation we wrote here, that is ID at the instant of 1, 2, 3 valve conduction mode. Because at that we are going to give, at this point we are going to give the firing pulse to 4, and now your 1, 2, 3, 4 are conducting, and then we can again here, now we are arrived here. So, today I am going to explain here. You will see in this 1, 2, 3, 4 are conducting. At that time we took here the expression I A rather than I B, because that time I 1 I A here it was equal to your I 1. But in this case it is not so, because 1 and 4 are conducting, means one phase here you can say the current of this 4 here is going and he is coming. So, this it is not completely I 1 current. So, it was not valid. So, what we did, now you can see in the upper limb only here this 3 is there, no 6 is conducting. So, we can say I B is equal to I 3, and we require the expression for I 3. So, here again we applied our E A minus this parallel voltage across this phase A, here phase B will be equal in that conduction mode, here it will be this, you can add, you are getting an expression here, very simple expression, that is your L d I 3 upon dt is equal to your this value E B. And now you can integrate for I 3, you will get this. Again we are starting here, this will be the conduction mode when we are going to start from I plus alpha plus 60 degree, means as I said here your 6, 1, 2, 3, then 1, 2, 3, here the end period was your alpha plus 60, here we started alpha, means this was your total 60 degree. So, now your 1, 2, 3, 4 it is your starting your alpha plus 60, 2 we are writing omega t. So, that is why here you can say alpha plus 60 is one integration constant and omega t is appearing here, and just it is integrated here, we are getting this value. We are adding plus current which was flowing, just this conduction was there. So, this is I 3 at alpha plus 60, that from the previous instant is added here, and then if you can simplify you will get at the delta here, that is alpha plus u degree, means at end of this conduction we are going to have this I D, which will be, because now what will happen, this commutation between 1 and 3 will be over, and now 3 at this end, that is your alpha, here it is your alpha plus u, here it is going to take place, and then we are going to have complete I D, because 3 is going to conduct. So, at the end of this is off, now this is this 3 on the top, only one valve is conducting. So, this will be the I D current here. So, you can from here you can simplify and you can get this expression. Now, once again, now we had in this case when we are having this is the case when u is your greater than 60, we got the two expression, one for the voltage and another for your I D. Here also we want to eliminate the u term, because u is varying depending on the system condition to condition, but I D is maintained and the V D we are controlling. So, we want to write the expression here, the V D, that is a function of I D, like the previous one we defined. If you remember, here it is your V D, it was your under root 3 V D O by 2, it was like that. Here cos alpha plus cos delta, here it was there, it was not under root 3, it was V D O by 2 cos alpha plus cos delta, it was the case. here VDU, because it was average of this, nothing else here. If you put u is equal to 0, it is getting the 2 cos alpha and it's cancel it. And but no doubt this VDU was your 3 under root 3 EM over pi. So we want to derive this was, it is not in terms of your that, it is not in terms of your ID term. We can write this one also. What was this? Remember, VDO cos alpha minus RC ID. This we derived from this current at the instant end, and this from here we got this expression. This is just like a voltage variator here. There is some drop, and that's why it is called equivalent commutation reactance. So similarly here, for this case also we want to derive from this ID, and if you remember the voltage equation we derived, it was, you remember anything? The VD was here this expression, and I wrote at that time here is a VD is equal to under root 3 by 2 VDO, and it was your cos alpha minus 30, and here plus your cos delta plus 30. No doubt this delta is alpha plus u. So normally we say this is your equivalent to alpha prime, and this is your, I can say it is delta prime. So we are getting the similar expression to the 2-3 valve conduction mode. This was the case when u was less than 60. So this is the voltage equation. We want to eliminate this because here u is appearing alpha plus u. So we can eliminate from this your ID current, and this ID we defined just previous slide, it was this value. So from here and here you can see inside terms are similar, only here the minus time is coming. So what we can do from this expression, we can take this cos delta plus 30 and then we can put it here. So this will be eliminated, and then you will have expression like this. Means here what we can do, we can from the ID I can write your cos delta plus 30 is equal to your this value, I can say it is a some constant IS3. So it is your cos alpha minus 30 minus ID by some constant, I can say IS3. I am not using IS2 because IS2 we use there. So if you put this value here, you are going to get, now you can see your VD will be, just put it here. So we are going to get under root 3 VDO cos alpha minus 30. Now we have to see if we are going to put here. Now this value is your ID, of course, into we are multiplying this. This value is your under root 3, and this value is your 3 under root 3 EM by pi, and this is already 2. I am putting 2. This is your VDO. Divide by IS3 here, because ID I already have written here. So I can write here, this is your, and this is nothing but I wrote here EM by twice omega L. Now you can see this EM is cancelled, this 2 is cancelled here, and now we can put it there. So this whole term we can write it is under root 3 VDO cos alpha minus 30 minus, now you can see 3, I can say RC ID, where your RC is nothing but 3 omega L divided by pi. Because in the 2-3 valve conduction mode we defined RC here, it was this value. So you can see here what we are going to get. This now in this case the RC is thrice of that mode. So mode drop is there. One is that alpha cannot be less than 30 degree. So you have to go after the 30 degree here. So this will also reduce the voltage, and there is a mode drop in this equivalent commutation. resistance here, that is the 3 times of the previous one here. So, now let us go for again the 2-3 valve conduction mode. We will see this extinction angle which I defined the gamma, and now this gamma is very, very tricky here, means you can see the valve voltages. This is the case of your inverter, this is the case of rectification, and this is the case when your U is less than 60 degree. Now, as I said, most of the time in this case the one period, this one where it is here, most of the time the voltage is the valve voltage is negative side. What happens, even though there is any spurious signal, this here this cannot conduct even though you are giving the gate pulse. Only the positive here is very small portion, but this is the reverse here, most of the time it is the positive, and there is a possibility due to the jumps or there is a not complete commutation completed here, the valve which was conducting it will continue to conduct, and that is called the commutation failure. So, that is why in the inverter circuit it is very, very prone to the commutation failure. No doubt the misfire can occur any time. We will discuss small operation of all these converters here, valves, etc. Misfire means you are giving a pulse and it is not conducting, means missed. But the commutation failure, that the pulse is given, the commutation is started, but due to the reversal and other things the commutation fails, means for example, if the commutation between 1 and 3 is taking place. So, the current here started decreasing and this was peaking, but due to the reversal of voltage across this, there is a possibility here the positive voltage it will pick up the current, because here the voltage becomes negative. So, what happens, this will be again going back here, because and the commutation may not occur. So, and that is called commutation failure. So, this period 1 here, it is, as I said, we normally maintain some angle, so that there should be proper deionization, proper commutation should take place, and this angle is called the gamma angle here. So, now they defined here the extension advance angle, sometimes it is also called the extension angle, and I said it is a gamma, and the gamma is the time angle between the end of conduction, here this is the end of conduction, and the reversal of the sign of the sinusoidal commutation voltage of the source here. This is a reversal here, you can say is going to reverse it. So, from this end of conduction of, let us suppose it is a valve 3, and here the sinusoidal voltage which is going to reverse the polarity from negative to positive. So, this is defined as a gamma. Now, in the commutation margin angle it is called zeta, and this is the time angle between the end of conduction, again we are starting here, and the reversal of the sign of non-sinusoidal voltage. Non-sinusoidal here we are talking, means there is a possibility that this can come here, we will see the different scenario, and then in this case your zeta and your gamma are same, because here it is going to reverse. Whether it is a sine or non-sinusoidal, it is going to reverse. So, in this case gamma and zeta are same, but it is not always true, and we will see in this figure. Here you see the various configurations, various possibilities are there. We had the, I showed you the previous figure was similar to this. You can see it was here the valve 3 was conducting, the commutation of this valve 3 was off here, and then it was following this voltage and it is going here. In this period it was basically the commutation of some of the, there is a 3 valve conduction in this mode. So, then it went with the half of this, then again it was commutation was complete, that is why it is U period, and then it is going here again and this. So, now this D, that is the dent, if this U period can change. So, what happens, this line can, you can see this line has come here. Now, there is a possibility even though D line come here and then sinusoidal picked up. So, these 3 possibilities are there when we are operating U is less than 60. Once again in U greater than 60 these possibilities are not there, because the most of the time the valve voltage is 0. Only 3 times it is non-zero, and that was nothing but it was half of this, that is a phasor voltage, 1.5 times of a phasor voltage. So, there was no dent, we just saw the wave shape of the valve voltage. The only possibility here in this case in the 2-3 valve conduction mode means U is less than, and this is also true when we are operating in the inverter mode. This is the case when we are operating inverter mode. In the rectifier mode it does not arise at all, because you see the previous figure, it is all the time here you can say this is all the time here it is negative. So, there is no possibility of commutation failure here, only the possibility, because only we are getting this time to get it deionized or getting it off. Here we are getting enough time, so this is no problem. Also, we can just see from our commutation voltage of valve 3, and as I said here we took this commutation voltage of valve 3 is nothing but your EBA. This is the valve 3 commutation voltage. Now, if your alpha is here, means you are giving a pulse to 3 here, this is your alpha, you have enough time to this valve to off, means it will go, no doubt, this is alpha and this will conduct, and there will be some U period where your this was your before that your 1 and 2 were conducting. During this period your 1, 2 and 3 are conducting. Then in between U the commutation is over between 1 and 3, and then again here this period onwards it is your 2 and 3 are conducting. So, you can see even though this angle is enlarging, no problem here the voltage you can say here it will be enough time, because you will see the negative voltage is appearing here across this valve 3, because once we here the commutation is over you can say still the voltage negative, and this huge negative is there, this will be off, and even though more time it is taking for the taking off. So, there is no problem here, but once you are firing here, that is inverter case, means you are just moving, you are delaying your alpha, and your alpha is now more than this, then you are giving a pulse here. Now, this will take your U degree, again here it was 1 and 2 were conducting, now 1, 2, 3 are conducting. Now, this here we are giving some margin, because this may enlarge somehow and the commutation may not take proper. So, here you can say now this voltage reversal is there. So, if it is not done here in this period, your commutation is not complete. Possibilities are this is a voltage is going to negative, and this again picked up, this 1 can continue conducting and 3 can again go off, means it will take the current and then again it will be 0, and that will be commutation failure. So, this period in the inverter operation we have the various possibility. That is why it is said that you should maintain this angle gamma I had said in the beginning, this is the extension angle you have to give, because this may keep on changing, because your beta also is based on some calculation. So, we will see in the control aspect this beta is decided by what margin you want to make. Suppose I want to maintain 10 degree here, then beta is being calculated. Why? Because this voltage can also change. So, it may take more time. If voltage changes, you will be changed. So, to maintain this we always to be sure that there should not be any commutation failure in the inverter side. So, we try to maintain this, then we calculate based on the voltage at that time, and then it will be fired. So, that is your controller will calculate, and finally, it will give the beta pulse. So, what happens even though during you have given the pulse to 3, but again the voltage changes at that time. So, that is why we maintain this angle. We believe that in that period it will be the commutation will be the successful. But if there is a fault, if there is a very severe condition, still we cannot tolerate this, and there may be commutation failure. So, we will analyze the commutation failure later on, and we will found that we will see that this commutation failure is self curing, no need to worry about this. In one cycle there is a commutation failure, next cycle it will take automatic. So, it is cleared fault. But no doubt this commutation failures are not allowed, because they are going to inject more harmonics into the system, that is dangerous. because our filters are tuned for certain harmonics. But once commutation failure happens, the output voltage is not symmetric and so many harmonics are there, and that is not desirable. So, here we will see now we are going to here the various possibility, and as I said here this is only the case when u is less than 60, because if u is less than 60, then only we are facing problem, because if u is more than 60, what happens, then you will find most of the time it is 0 the voltage, or it is negative, there is no dent, and that is a very severe abnormal condition we never allow. Normally, the 2-3 valve conduction is very, very common always, because u is there, whether it is a 5 degree, 10 degree or 20 degree, it will be there, and that is why we are having these scenarios. Now, so all these 3 conditions are arising if your beta, it depends upon beta basically, where you are firing here, you are firing here, you are firing here, and all these possibilities are taking place. So, you can see here if your the condition means we are having 3 different stages, and in that stages I can say in stage 1, if your beta is less than 60 degree, beta is less than 60 degree, this is your first case. Means here the beta is less than 60 degree, then we are always having our gamma is equal to your zeta. Now, what is the gamma? Gamma we define it is your beta angle from here, and this is your u. So, we are having it is your beta minus u. So, you can see if you are maintaining this gamma 10 degree, it is always your commutation is successful, because we are here, this is no means by this time it is we are having this angle zeta. Now, if your beta is, you can say if beta is more, now you can see this is a very different scenario. What happens, this is now coming this side, then problem starts arising. If you are coming here, it is not problem, but to maintain this is also another problem. If you are coming here, let us suppose your beta is itself 170 degree, so gamma is not maintained, that even u is something, it is coming somewhere else. So, that is going in the different mode. So, if your beta is your greater than 60 and it is less than 90 degree, then we are arriving at this stage 2. In this what happens, now for example, I can write at this moment what is going to be fired. Before that, your 3 and 4, well, let us suppose this is the valve output of valve 3. If I assume this is the valve output voltage of valve 3, means at this case now it is coming voltage, means it was conducting up to here, means there was a commutation between your 3 and 5, means it is over. Now, here your 4, 5 are conducting, means I can write here on the slide itself, means before that we give some pulse, but here onwards your 4 and 5 are conducting, and this will go up to here when your 6 is being fired. Once 6 is coming, means there is a commutation between the 4 and 6 is taking place, and since this is there here, the voltage becomes here is minus EC by 2. So, minus EC by 2, and here it was conducting, so it is minus 1.5 EC, and that is why, no, this minus is a minus, so it is a minus 1.5 EC, and that is why here it is coming here, it is a following this EC 1.5. So, this period basically during this your 4, 5 and 6 are conducting. Then here it is off, and now here onwards your this 5 and 6 are conducting, and then again we have to there is, yeah. So, it is keep on the same repetition Now, in this case, once your beta is more than 60 degree, what happens? This dent is going to be larger, because you can say for same, if the beta is more here, here beta is going to be more and u is same, then we are going to have this angle is wider. Now, what happens? Now, this is going to shift, because always this period, when your this period and your firing means next valve firing, it is a 60 degree, because always here you are getting 3 valve, after 60 degree you are giving valve 4 and so on and so forth. So, what happens? This is going to be changed, the width is going to change depending on your beta and the basically u as well. It is less than that. So, this is going to be wider, and there is a possibility it is, you can say, just it is a shifting here and we are having this one at this point. So, as per our definition, now this is the smaller portion is your zeta. I said the end of the conduction and then non-sinusoidal reversal of the voltage. So, here reversal here. So, this is your zeta, but as a gamma definition, end of conduction here, then the sinusoidal voltage of outgoing ball, the commutation ball. So, this is your gamma. So, now you can say zeta is this much. So, now we have to maintain the zeta. What happens if zeta is not there? Now, voltage becomes positive, and again there is a possibility of the commutation failure. Another possibility, you can say, if the beta is more than 90, this whole dent is coming below. So, in this case what happened? Your this value is going to be your zeta, not this dent, this value, because here the reversal, always we are talking the definition, end of conduction here, and then the reversal of non-sinusoidal voltage. Here this is your gamma. So, this is a, this value is there. So, we are having the different flavor, different values, 3 stages, and that is why here you can say the dent is entirely above the horizontal line. This is horizontal, your 0 axis. Here the dent is always above in the first stage, when your beta is your less than 60 degree. If your beta is between 60 and 90, what we are getting, we are getting this dent is basically half of the below and half of the above. Okay, this is here, this front of the dent is partly above and partly below this. This is a front. The front is half below, half above. But if it is a more than 90 degree, this complete here the front is the complete the below the horizontal angle. So, this your zeta is very, very important, and if you are in this mode, you should be very, very cautious. But normally we operate our inverter in this mode. Why? If you are coming this side beta more, the power factor becomes very, very vast. We try to fire here only in this one less than almost 30 degree, not more than that. So, always we are getting this, but there is a possibility due to fault etc., you can come this side and the commutation failure may occur. So, here just as I said, the beta is basically being calculated. Your controller will calculate, because we want to maintain this, beta will be calculated, something happens here, you are landing here, either here or here, because the calculated beta may be less than 60 degree or maybe more than 60 degree or maybe 90 degree. So, that time your all the scenario is going to be disturbed. So, this is a very important, because the zeta is more important, because we have to maintain the zeta rather than gamma, but in the normal case gamma is sufficient, because as I said we are operating our inverters less than 60 degree to maintain the reactive power support etc. So, at that case both are same and our commutation is successful. Now, let us move to our 12 pulse. This is 6 pulse is over. Now, in the 12 pulse, as I said, there are so many configurations are possible, but it is very convenient to use the 2 6 pulse bridges and then connect in the series, and then output will be 12 pulse. You can have 6 phase windings, and then you can use your valves in a such a fashion that you can get, or you can have this the 2 bridges 6 pulse. Only the difference here, the transformer you are using here is a delta delta, a star star, and here you are using star delta. Means secondary of one of the bridge should be in the delta, and the secondary of 1 will be in your star. What happens due to the star and delta here, you know there is a 30-degree shift. Again the 30-degree shift depends upon whether the plus or minus, it depends upon the dot polarity. If the dot is changed here, then it will be negative. If this dot here, it will be shifting 30-degree. Now to understand this, we have drawn for this valve voltage. Let us see the what will be the output voltage here with the case of this. Because here it was this A minus B, here it is AB, means this is a phase A voltage here. So let us draw the output voltage. So to say here, as I already mentioned, here we are going to analyze the two 6-pulse bridges. One is connected with the transformer star star, another is the star delta, and they are in series. So we are getting the 12 pulse here output, means both voltages are added together, algebraic sum simply. So they are added and they are used because this provides 30-degree shift. So 6 and plus 6 in same cycle, then it will be the 12 pulse. This configuration, as I said, we are using higher output pulses that we can minimize the AC side harmonics as well, and as well as the DC side harmonics. Because AC side we will see analyzed later on. Here the AC side, as I said, your NP, the characteristic harmonics will be this, and the DC side it will be your NP. P is the number of pulse and N is integer. Now it is a 12P here you are getting, the 12 here 1. So 12, 4, 24 and 36 so on in the DC side voltage harmonics are there. The current harmonics in the AC side, it is now 12 here, now it is 11, 11, 13, and here you are going to get 23 and 25 or so. So we have, however, if it is 6, it is your 5th and 7th, then we are having 11 and 13 and so on and so forth. So this is going to be cancelled out because the harmonics generated here and here, they will be cancelled AC bus here where the transformer. So let us see the case when U is 0, and then we have to draw the case for this one. Already we have drawn for this case. Here I want to show where we have to start. Now again we are taking that here 1 prime and the 2 prime, the valves number are conducting. Now 3 is going to be fired. What will be the voltage across the at that time? It will be only conducting when the voltage across this will be positive. So 1 here is coming A, here it is B, means you require EBA is positive. Okay. What is EBA here? See it. It is nothing but it is minus EA. The phase voltage which is here, we are talking here line to line, but this is equivalent to the phase voltage here. No doubt this phase voltage we are going to transform in such a turn ratio that it will be under root 3 times of the phasor voltage of that side. This side it is a simple your, as I said, star here. Here. So this the transformation we are taking care because magnitude should be same here under root 3 times here and line to line here, then we are going to add. But here we are going to get this is minus. Now you can see this was our case, we are again starting here this EBA, it was the case for this case here first phase, and we took the third valve commutation voltage is your EBA because 1 and 2 were conducting. Now the lower voltage here I am going to draw for this one. So this was your EB, it was your EC, it was your EA, and finally this was your minus EA, this is your minus EB, and here we are writing this is your minus EC. Well, now you can see in this topmost figure here, means we can start alpha from here any time, means we can start here because the voltage across valve 3 in the star star connection 6 pulse converter, here we can fire and then it will conduct. If you are delaying some angle here alpha, hardly matter, and the voltage will follow and it will conduct. Coming here, now you can say the voltage across that should be EA, minus EA positive, because minus EA should be only positive, it is going to be here, and this degree is your 30 degree, and this phase shift is there. So, your first valve is fired here, the same pattern is your alpha degree, thus here it will be alpha plus 30 degree. You cannot fire because this is cannot conduct, because you have to wait here. So, the alpha here coming all the way, now alpha start here, in this case alpha start 30 degree there, and that is why let us draw here the output voltage, means here I can say alpha start here or 0, but in this case here alpha will start from here, means this is your alpha, this is your 30 degree. So, if you are going to delay here alpha degree here, then you are going to delay here alpha degree here. So, only difference due to this is here due to the phasor and 30 degree shift, otherwise there is no difference. So, once you are arrived at certain here, that is now we are going to start from here, that is alpha degree. Now, we can see what will be the output voltage for your u is equal to 0 and alpha, let us suppose I can take a 15 degree, and then we can draw. So, let us see what will be the output voltage here across that I can say VD2 when we are having the delta here that is connected with this bridge. So, as I said, I am going to take alpha is equal to 15, means here I can say we are going to draw is equal to 0 and alpha is equal to 15, although this u cannot be 0, it can be some value, but for this case we can just take alpha is 0. You can take alpha some value and then there is no difference, because already we have seen for this mode. So, it will only there will be this period the commutation will occur. Now, you know this complete period is 60 degree. So, this is your 30 degree, means I am going to fire here, your I can say 3 is going to get the pulse. Once 3 is getting pulse, here it will conduct, because the voltage across this valve is going to be positive, means minus EA, which is positive during that period, and it will conduct. Now, what will be output? Now, this is a 3, 2 means 2 and 3 are conducting. Now, the 2 and 3 means 3 here and the 2. So, C here. So, we are getting the EBC. Here the voltage we are getting EBC will be, what is your EBC here? This is nothing but your phase voltage of this is EB, because this I said it is a positive polarity. So, EBC is positive here. So, it is your EB. No doubt in this case this phasor value is a line to line, although you can see here I have drawn the magnitude is less, but it is not so, because the same graph we used for previous case. So, it is same there, otherwise magnitude is same here, it is going to be this, because it is the turn ratio in such a way that we are getting line to line voltage equivalent to the phase of this side of the transformer. Okay. Now, we are going to have the EB. Now, you can see what is the voltage is going to appear. It will be suddenly going here and it will be conducting here. So, output voltage is going to be EB, because EB is there already we have marked and it is a positive. Now, after 60 degree your valve 4 will get the pulse, and this after 60 degree it will be here, means your 4 is going to get pulse. Now, 4 is getting pulse here, means commutation is instantaneous we have assumed, because u is equal to 0. So, what will happen, your which one is conducting? 3 and 4 are conducting. So, it is B and A. So, it is your output voltage here, it is a BA. So, EBA, you see what is EBA? EBA, it is the negative of this phase. So, minus here it is your nothing but minus EA in this case. All these we are talking, this case is not with related to this case. So, this case is a different. So, here and you can find minus EA is just on the top of this. So, it will go up to here and then output voltage will be this, and it will follow your here. So, again it will be here, it will be getting the 5, then it will be getting here 6, then it will be getting here pulse 1, then here it will be getting 2, and then again it is your 3, means we are completing the cycle. And you will find it is all the time we are getting here, if your fifth is going to be fired, we are going to get this output voltage. So, this will be your output voltage, and you can say this is a positive because we are operating in the rectifier mode, and here it is all the way here. So, this is just similar to the previous case, and you can say it is here the similar we are the output voltage that we are getting. Now, this here if you are going to draw for this one here, already we have drawn for the previous case, the alpha which we are giving here, now it is going to be your EBC. Once 3 is going to conduct, here the B and your 2 EBC will be there, and the EBC is nothing but our EBC is this. So, here EBA, here we can go ECB, here it is AC, and this voltage is going to be ECA, and this voltage is going to be EAB, and so on and so forth. So, what happens here, now you are getting here the pulse 3. Mind it, here it is all the primes, means we are talking for this bridge. Now, I am going for this bridge where the no prime, means here 3 is getting here, this basically we are moving ahead because this is a 30, this is a 15 degree. So, this is your 4, this is your 5th, here is your 6, here we are getting 1, here it is your 2, here it is your 3, and again it is a cyclic process. So, what is happening here, it was conducting here, output voltage comes something here, and then we are going to have this output voltage. Already we draw for this output voltage in the previous turns. Now, you can see here both are the same pattern and the same magnitude. Here this is looking slightly flatter, the reason is that this is smaller in size. If we increase this, it will become the same shape, because here this is not to the scale to this one, because I said it is also line to line now, this is also line to line. Now, you can see the peak of here, this is here, you can see in the between. So, this is going to be superimposed here, and we are going to get the 12 pulses output outside, and I can simply draw here, this is our output voltage will be here, this means 1 here cycle we are going to have the 2 in 1 period, because it is 30 degree shift, because it is conducting for 60 period, in between the 30 shift. So, we are getting another pulse, and then finally, we are getting this total of this here and here, and 12 pulse we are getting in the single one cycle. So, this is your 12 pulse basically the case. This is the lower bridge, this is upper bridge, add together and you will get it. Even though sometimes you can draw both on the same here, no problem, because only you have to find where is A, the B will be here. So, but magnitude will be the same. It is 1.5 here, you have to go for here, the line to line, and then you can add together. Now, the another concern here, how this harmonics is going to be different. In this case, we also draw what will be the current in the phases. I am not talking about the wall current, I am more concerned about the current in the phase, because that will create the harmonics. So, if you draw the current pattern here, if you are now you can start the which period which one are conducting. In this period, your 2 and 3 are conducting, here 2 and 3, here 3 and 4, because 4 is coming. So, it is 3 and 4, here your 4 and 5, here your 5 and 6, and so on so forth. Here 6 and 1 are conducting, and again we can go for here 1 and 2 are conducting, here 2 and 3 are conducting. So, before here your 1 and 2 are conducting. Now, once the 3 is given pulse, here this phase B current will be this, it is going to conduct. Now, let us draw for only one phase current. It will be symmetrical, only the shift will be 120 degree. So, we can start here, because 3 is getting pulse, the current here through this phase A will be some current here ID. So, okay. and it will go all along till 3 is there. It will go up to 120 degree here, because the commutation between 3 and 5 is going to be over. So, this period is your 120 degree. Okay. Now, the commutation is over, only 5 is taking. So, in the period when 4 and 5, you can see this is going here and coming all the way here, this both are off, and that condition the current here will be 0. So, this will be 0 up to here, up to the 6. Now, you see once 6 is getting pulse, means here the current is going to be a negative side the phase, and it is coming the below here, and I can see it will again go for 120 degree, because 6 is there. So, it is again this value is your ID here, and it will be going to again 120 degree. Then here 1 and 2 are there, means 1 here A and the 2 C. So, B is again 0. So, it will be again 0, and we are having this the current. So, this is we are getting the current phase B current here. Similarly, we can draw for phase A, phase B, C, and it will be simply shifting, nothing else. Now, let us see here, that is more tricky. In this case, again we have the patterns of conduction here, because when your 3 is 3 prime now, it is going to fire, means your in this mode 2 prime and 3 prime are conducting. In this case, your 3 and 4 primes are conducting. Here your 4 and 5 primes are conducting, and in this case your 5 prime and 6 primes are conducting. Now, we can start from here. Now, you see your the case when 2 prime and 3 prime are conducting, means this current which is coming here 2, where is it 2 and 3 primes, here it is your ID, because the ID is going all the way here. The same current is flowing here in this ID, because this is a series circuit. So, this ID is coming here, this ID in the coming here, this is 3 and 2 is going to return here. So, 2 prime and 3 prime conduction here, means this ID is going here, and this is your ID going here through the 2. Now, you see this is here, this current is 0 at this time. At this point, you can see this current is coming here. Now, there is a 2 paths to come here the same current. One is through this, another through all the way here, and then here, and then it will be going. Now, this current ID is coming here. Now, you can say here the 2 impedances are there, here the single impedance are there. So, it is divided into according to impedance. So, here 2 ID by 3, and here it will be ID by 3, and it will be going, and finally, it will be ID. Okay? Because 3 impedances are there. So, it is a 2 come here, because here half will be there. So, now, you can see the current between the phase B. Now, I am interested to draw the phase B, and it is coming out from the positive terminal, which also we talk here the positive terminal. So, this will be the positive 2 ID by 3 when this is the period, means during this period when the 2 and 3 are there, it is not ID completely, it is slightly less here, and this was your 2 ID by 3. Now, after that 4 is getting pulse when 3 and 4 are conducting. Once 3 and 4 are conducting, now you see what happens. Again the current here, it is your ID which is going in the 3 and 4. Now, it is coming here the current your ID, because this is going here and it was coming all the way here, where that 4 here. Now, this is going, now this is 0. Now, we have to see again the direction of currents here. One will be coming here because it is returning, and another will be here through again here, right. So, in this case now you can see it will be ID by 3, here 2 ID by 3, and here again it is your ID by 3, means it is reduced by half of the previous case. So, we are going to have here it is half of this and it is going to be here, and again you can see the polarity here is the positive coming out from the dot polarity. So, it will be positive. Now, when 4, 5 are there, 4 and the 5 means here it is going to be here ID, and the 4 this is 0 now. So, we can again just analyze here what will be the value of this currents. So, this is your this current is going to be here. So, your 2 ID by 3 will be this. Now, this you can say here it is going to be reverse of this, because this current is coming now, this is here and this is coming all the way here, because this current is 0. So, now it is become negative of the previous one, and again the magnitude is ID by 3. So, we are going to have here this is the same magnitude, and here your up to this it will be conducting. So, it is your ID by 3 negative side we have drawn, and again if you will go further you will find it is a 2 ID by here, this is your 2 ID, then again you can have the here ID you will find, then you are going to have again here you are going to have this one and here. So, we are going to have this current here as well. So, we are here the current this is a ID by 3, 2 ID by 3, ID by 3 minus ID by 3 minus 2 ID by 3 minus ID by 3, ID by 3 positive, here 2 ID. So, this is also a sinusoidal wave shape is there. Now, if you are adding here, now you can see at the some time here it is this positive and it is a peak. So, it is a high spike positive, some portion even the half of this it is added this much only. It was 20 degree, it is only for 60 degree. So, sometimes it is adding complete this peak is added here. So, it will be peak, and if we will go for this adding, then what we are getting? We are getting this here, this period is the highest, means this is we are getting this is here and here. We are getting the 6 pulses again here in this cycle, and you will find this will be not there, it will be here, and you will find this is a perfect sinusoidal. This we are going to get the current, which is better than the previous one. Here you can see in this figure we are having the sinusoidal here, and the more harmonics are there. Here also we are having more harmonics. So, due to these two additions, some of the harmonics, as I say 5th and 7th are cancelled to each other, because one will be positive, another will be negative, and adding together and that will be cancelled off. So, this is basically the 12 pulse current, and this is only due to the shifting of this is going to take place. Now, let us see here in this case. Now, the previous ones we were analyzing only 6 pulse, we had basically the 2 modes. One is if your u is less than 60 degree or u is greater than 60 degree, because in between is another condition, even though we can define, but when u is 60, but we can differentiate here, because here end of this is 3, here starting of this will be at the 63. We had the 2 modes. Now, in this case we are having the 4 modes. Now, instead of u 60, now u is changing with the 30, because once 30 is there, remaining it is a 30 shift. So, it is going to act in that way. So, when you are having u is less than 30, then you are having 4 and 5 wall conduction, means in one bridge it will be the 2, in another bridge it will be 3, sometimes 2 2, then path will be there of course, and due to this u there will be some commutation will be occurring in either of bridge. So, once u is less than 30, you can see you are here, and then if your u is more than that and less than 60, you are going to have 5 6 and so on so forth. And this case when is the dead short circuit again, once 8 valve is conducting, means 4 valves, 4 top and 4 here, means is a dead short circuit. So, this is again abnormal condition, but here you can say u is less than 30 is also critical. Means if it is more than that, you are going to have sometimes the 6 volts conduction 3 at the same time, and the huge voltage reduction is there. Moreover, if you will see the current already I explained here to you, and now you see the due to this conduction pattern, we are having the extra dents here that is arising for the lower one. You see one dent was coming from the top, and this was another just dip here. It was arising if the 6 pulses were there. Now we are going to add, due to that conduction of the another effect, we are getting one dent here, another here. I can say D prime or D double primes are there. So they are going to be added. Now you can say if you are operating in the 12 pulse mode, now this is more severe, because this is coming earlier to this. So the commutation again becomes very critical. As I said here, it can go fall down here very easily, and you require U is less than 30 degree. So here in the 12 mode, again we are very cautious that we should operate your beta here, even the beta should be less than 30 degree. If your beta is more than 30 degree, in this case, as I said here, beta is less than 30 degree, you are having the gamma is equal to zeta. But if your beta is greater than 30 degree, here you see you are here, and your gamma is reduced, you are having zeta. So normally in the 12 pulse converter, we operate here less than your 30 degree beta in inverter operation. So with this, I can close this, the whole wave shape, etc. On the next turn, we will just talk about the all this VD and ID. We will go for the characteristic, this electrical equations purely, and then we will see how the operation, etc. can be decided based on the charts, that is VD and ID, power factor, etc. You can say pure electrical we will analyze. So with this, I can close this lecture number 9, and we will have another lecture on the converter charts on the next time. Thank you.